Recording is started.
All right. So, got a relatively short list of agenda items today, but I'm sure people are anxious to get onto multi-networks after the discussion on the mailing list. So I want to just start with going through them in order. So Chris added a topic about 1.7 feature list confirmation. Chris, are you on the call? No.
Yes, sorry.
Um, is that Chris?
Is Tim in that conference room too, by the way?
Can you hear it?
Are you muted?
No, I'm not muted.
So we can hear you guys. It's just kind of quiet.
Oh, okay.
Let's just move it closer. Just for this.
Sorry, we're sharing a laptop here.
Okay. So this morning was the feature discussion meeting for the Kube planning for 1.7. For whatever reason, the two features that I thought were pretty much confirmed to go on 1.7 were tagged as no milestone, and the two that probably should not have been tagged for 1.7 were. So the two that were tagged for 1.7 were RPGS and node local services. And from what I can tell, there's been a lot of discussion still around the design around these, and I do not think that they are fleshed out enough to be considered for the 1.7 cutoff. But the other two, which were network policy to GA, and also another one around GKE for source IP preservation, probably should be included for 1.7. Does anyone disagree with those? So we pretty much need to flip the labels around on both of them. And I can do that. I just wanted to confirm with everybody.
So I think that sounds right to me in terms of what should be in 1.7 and what shouldn't be. The spreadsheet has a little bit more of a granularity there, right? So there's a target for 1.7 that could be set as documentation or so on. But in terms of the features repo, yeah, I think it's network policy and the source IP preservation that are actually valid for being GA in 1.7.
Okay, so I will flip things around and I will move the 1.7 milestone for the two that have it right now.
Yeah, it also sounds right to me. I don't think we have much of an agreement on any of the other things there.
Okay, great.
And when we talk about network policy, we're talking about as it is today, not any of the other additional work we were discussing or possibly including in GA.
Correct, yeah. So I was just starting to have a go through that spreadsheet to make sure that it was as up to date as it could be and that the right owners were assigned to things. But I think there are still some like rows in there that don't have owners. I think it would be great if somebody thinks that they are working on a feature in the spreadsheet, if they could either fill in the owners column or reach out to me to say that they think they're the owner for it, and I can update that.
Did you edit the deprecate KubeNet owners field?
Yes.
Okay, because Dan Nardo is the owner of that. I just put myself there as buffer, basically.
Okay. Sorry, I missed who you said was the owner on that. You can just Slack me the GitHub ID.
Yeah, I'll change it.
Yeah, this is Bowie. I think everyone should be able to have write permissions on that spreadsheet, so you can put it
So Dan, I put Dan Winship as I'm not sure. I didn't notice he was on the call. Put him
Yeah,
as the
no,
owner.
he's on PTO, I think, all of this week.
Okay.
But he should be the owner of that one. And if I remember correctly, it was Chris Marino had talked earlier about working on some of the IPv6 support, I think, for Cube. I'm not sure if he's interested in continuing being the owner for that one.
Yeah, just a note, if there is something in here that's definitely supposed to go on 1.7, it does not have a feature release, so kind of the time has passed for anything new. I imagine a lot of these things are going to be spread out over several releases, so it's probably not a big deal. The ones that do have feature releases, though, that do need about 1.7, that's really all I had on that topic. Unless anyone has very notes.
Yeah, if you have even a multi-release feature that was talked about, discussed, but is not in that spreadsheet, please put it in that spreadsheet so we can kind of keep track of it.
Yeah, that would be great. I think moving forward, it would be really good to keep this up to date and make sure these features have owners associated with them and that we're regularly reviewing and making sure that it's on the right track. So the next topic was also from Chris, Flake report.
Yeah, so I put the high visibility flakes. I need that high visibility just because it's blocking a lot of builds and comes up on the mailing list quite often. And that is 2 of them here. The service endpoints latency, which I think you mentioned, seems like it's, wait, both of these seem like they're cross-cutting, but it really probably should not be owned by SIG Network because they're.
Yeah, so I commented on those. I'm trying to track down the other team to try to hand it off. Just it seems not related to networking, so I guess I'm owning them right now.
Okay.
Should we remove the label from the nodes not ready one then if it's most likely not networking, or keep that for now?
Let's keep that for now because I have to hand it off.
Got it.
What happened is basically it's fallen in the cracks, so let's just keep it for now so it's on our radar in case it doesn't get fixed.
Yeah, I also try to look at the flake mails when they come in, but it seems like somebody beat me to that this week, so thank you for that.
Yeah. Other than that, I think those are the only 2 on our radar.
I do have to say there are a number of flakes that just have the SIG network tag, and if they're not still flaking, should probably just be closed. I think I counted like 20 some that are linked in the doc there. So I imagine a lot of them are duplicates, and we should probably just close them if the test data hasn't shown that for quite some time. And they're not related to the 2 critical ones. I think they all should be assigned to someone. Yeah, there's 23 currently open.
Where are they assigned to?
The next link. Myriad of people.
Okay.
Basically, anyone that could have a flake assigned to them, it has at least 1.
All right. Maybe I'll take a look at those. What they are.
Like I said, a lot of them are like crusts.
Yeah. That's,
So it
that's
could
the
just
ones
be
that
like-
never get solved.
Yeah. Okay, that's all from me then.
Yep.
Cool. So did we, was the outcome there that people who have flakes assigned to them should check if they're still flaking and make sure they get closed if not?
Yeah.
Are people aware of whether or not they have flakes assigned to them?
Even if they don't have flakes, they should probably just go take a look and triage them anyway.
The flakes issues that I have there, that contains all of them that have the label of SIG network. So just take a look at that, see if they're on them.
Awesome. Okay. So unless anyone else has small things they wanted to talk about, that brings us to the multiple networks discussion, where I know at the end of last week, we had asked everybody to go out and come up with their list of use cases for what we've been calling multiple networks. And Dan was nice enough to have a go at compiling all of that into the top of Joji's proposal. Do we feel we have had enough time to review and digest all of those use cases and form opinions on them?
Probably not.
I know I have only been able to get a skim of your compiled list.
Yeah, sorry. I spent a lot of time yesterday putting those together and then ran into a conflict yesterday night, so I wasn't able to get that out to everybody by this morning. But I tried to just basically go through various documents, the mailing list, discussions, GitHub issues, etc., where we had discussed these things and kind of put together all the ones I could find. I made no judgment about whether that use case was relevant or not, or whether it was cloud native or not, or whatever. I just took them all and put them in so that we could at least get a broad overview of what people want to do with Kubernetes before we start discussing each of them individually. I mean, one thing we could do is we could just start going down the list and talking about them. And if anybody has a question about exactly what is meant by that particular use case, the person can explain it, or I can try to explain it. And then, I think, as was pointed out in the mailing list, maybe we just want to take a look at them to start with for the first few minutes before we actually start diving into what I think the contentious areas will be, which is this a use case that Kubernetes should try to address in some way, or is it a use case that Kubernetes should punt out to the plugin either through third-party resources, annotations, or some other mechanism? Otherwise, I'm open to suggestions for how to start discussing these and trying to achieve some consensus.
Yeah, my one reservation would be that I'm wary not everybody may have had a chance to look at it, and it might, maybe we can spin through them together, but it might be best if people have a chance to review them on their own before we try to go too deep into them.
Okay. I guess.
But yeah, I could see it going either way.
Maybe one thing I tried to also summarize some of the themes of the use cases that I feel like I could pull out at the bottom of that list. And I think one thing two aspects actually. The first one being, I feel like if there's a case to be made that a particular pod could use or could want services on more than one what we call network, I feel like that is an indicator that maybe there is something Kubernetes could do to help there. And I think there are a couple of use cases in there that might benefit from that. There's other use cases, I think, like, I think I called out the storage network and legacy app network cases where those, if we want to talk about actual interfaces into the pod, if we just accept that, maybe that's the way the pod wants to do it, some of those interfaces, like those used for a storage network or those used for talking to, say, like a legacy database, those probably don't need services because it's the pod going out and talking directly to those things as opposed to the pod providing a service on that particular IP address of that interface. So I thought that was kind of a differentiator that I could pull out from some of these cases. And maybe, just throwing that out there, maybe for the storage legacy app network type use cases, those aren't things that we explicitly address in Kubernetes at this point, although I could see how if we solve some other use cases that those storage legacy app things would kind of slot right in. So I don't know. I'm just trying to think about, ways that we could either reduce the problem space or that we could start from a fairly simple solution to try to address some of the use cases and then, get something down so that we can continue the discussion, but still, solve one or two problems at least.
Yeah, I agree with trying to reduce the problem space. When I cruise through this, I'm not convinced we really have a use case like you were talking about earlier, where you need Kubernetes services to be on more than one interface for a given pod.
I guess I would. One of the cases that I was thinking of, the IPTV case or media streaming, I can see where you might want a service for the control or management plane and also a service for the data plane.
It's the second part I was struggling with. Can you explain that?
I'm just thinking in terms of, say you have a set-top box, and that set-top box wants to request a channel. So it has a command, not a command service, but like there's a service that the set-top, when you switch the channel, the set-top box sends a command to a particular service, and that's on a low bandwidth interface. I mean, obviously on your set-top box and your pipe to the internet and your provider, it all goes over the same bandwidth pipe, right? But in the data center, that would potentially be a completely separate service in a separate network or whatever, but low bandwidth, latency doesn't matter, throughput doesn't really matter. So that goes to one interface in a container, but then the container also has, whether that's SRIOV interfaces or either some physical NICs on those machines, it has another interface that is solely used for media streaming. It is high throughput, and because that node or that pod might serve many different clients, you're not limited by that one bandwidth. But that service also has, that media streaming part also has a service. So you essentially might have two services in this case. One is the control that says change my channel, and then the other one is the IP address or the service that actually receives the media from the transcoding pod or the actual streaming pod or something like that.
Yeah, my expectation was that the media streaming would be using protocols that are defined in some IETF or broader community than Kubernetes, and they're not going to have Kubernetes API in them.
Well, I'm saying they wouldn't have Kubernetes API, but
not even Kubernetes services. I mean, there are existing protocols for media streaming, and they don't require Kubernetes services to use them.
Right, but what I'm thinking of is in terms of thinking of the service in terms of a way to have one particular address that then goes to an arbitrary backend. I mean, I know currently the proxy stuff is more or less limited to, I think, TCP and UDP, but a lot of these streaming stuff is based on UDP. And so that could still be plumbed through, kube proxy. But, at this point, if you're talking about performance, you may or may not want to actually use kube proxy, but you might still want to use services and, DNS lookup or cluster IPs for that particular high performance service. So I don't know if that makes sense. That was the use case that I was thinking of there. That's sort of a variant of what some installations I know of are already using in a sort of hacky workaround.
Question: are these guys? Is the set-top box is outside the Kubernetes cluster, right? It's not going to even use a cluster IP address, even if it's a service's virtual IP address, right?
No, I mean, maybe I wasn't clear. Think of the set-top box as a client of some service in the cluster. Exactly the way you'd run like an Nginx service in the cluster, and on a mobile phone somewhere out there, you talk to that Nginx server that's inside the cluster. Does that make more sense?
Well, yeah, for the control management plane, but for the data plane,
so one of the use cases is multicast. So that's one where you'd want a separate interface is for multicast and not have that go through the egress services.
Right, but I think what Mike's asking here and what I'm trying to probably badly explain is, would that other interface and the IP address assigned to that other interface require a Kubernetes service or not? And maybe the contention here is that if it doesn't actually require a Kubernetes service to reach that particular endpoint inside the pod, then maybe it's not something that Kubernetes really needs to add to the API for that use case. At least that's where I was kind of coming from. If that makes any sense, Mitch.
Gotcha. Yeah, I know in Comcast they're writing some custom CNI stuff for a multicast interface for the whole VDE, which was the keynote at KubeCon Seattle.
Yeah, I mean, that said, for all of these use cases, it would be nice from the management and statistics perspective if Kubernetes had some idea of what these interfaces were in the pod. But from what I was hearing on the mailing list, the contention is that multi-networking would add a lot of complexity to the Kubernetes API. There are some users who don't need that complexity. And so is it worth adding all the complexity just for management and statistics and control if some of the other parts of the API aren't even going to be used? So I don't know. I feel like I'm kind of wishy-washying here on it.
Maybe it would be useful to discuss the complexity we're talking about. It's a scary word, but we've kind of agreed that some of us are going to be biting it off, some of it off anyway. I'm not quite sure I have a firm grip on all the complexity we're talking about.
Yeah, so I think in my mind, I'll try to say it briefly and shut up and let somebody else talk. In my mind, the base complexity that we could have is adding a network object and adding kind of basically what's in Joji's proposal, except skip the idea of services for now and kind of punt that down the road and figure out how services work with multiple interfaces later. In my mind, it's not really the point of Kubernetes to say how packets get to the nodes so much because that's so dependent on the network plugins. But once packets get onto the node and get into a pod, then, even in some ways that's kind of the purview of the network plugin as well. I think where Kubernetes has things to say are more around cluster-wide concepts like load balancing, ingress, those kinds of things. And those we don't really have a great idea right now of how they interact with multiple interfaces. But in my mind, I don't feel like it's adding too much complexity to Kubernetes at this point to just have network objects that call particular plugins, and then we pass some IP addresses and interface details back to Kubernetes that can present it through the API. But I know others might feel that is complexity for not enough benefit, since it doesn't actually use much of the Kubernetes model. So that's my piece.
I tend to agree with you, so I'd like to hear from someone who disagrees.
Possibly they're not on this call.
Right, so again, let me just say, right, I'd like to put a stake in the ground that says maybe what we could do is allow talking about, have these first-class network objects, give the option that in a pod spec you can request multiple attachments. The pod data model can record multiple attachments, but we don't try to worry about general problems in getting these addresses into endpoints. We have some simple convention like the first IP address is the one that goes into endpoints.
Yeah, I think it's important to point out you can create your own endpoints through the API too. There's nothing that prevents kind of side creating all of these things. It's just it'd be a lot easier to do so through the Kubernetes API if Kube helped out a little bit. But unfortunately, I don't see Tim and Christopher L. from Tigera, I think, and Thomas Graf. I think those people were some of the more vocal in questioning some of the use cases. So maybe we don't have enough of a quorum of the other side of the discussion.
Yeah, it does seem that way. I think a large part of it was just, we don't have a clear idea of where is the bar for putting things into the Kubernetes API. So in addition to gathering up these use cases, we kind of have to set that bar and then analyze them against that.
Yeah.
So I think we've we've got this list of use cases and we can start to understand those. but it's something we also need to be thinking about is, where do we draw the line between this becomes a first-class citizen or this becomes something that we add the extension points for, and focus on building those extension points rather than coding it into the API.
Yeah, one other point that I kind of came out of some of the use cases was there was an interesting use case from Huawei about multi-network per node, but not per pod. I think it's kind of an extension of the CNI Genie sort of thing, which is you still only have one network per pod, but you might have multiple network plugins available on the node, and you want to call a different network plugin potentially for each different pod. And that was kind of an interesting use case because it basically avoids the whole service issue because there's only still one network in the pod. And so therefore services and everything like that more or less work. I thought that was kind of even that use case might be a use case for multi-networking in Kubernetes that isn't as far down the rabbit hole as some that we have. And then I think the other thing that I wanted to bring up was that maybe if we cannot achieve consensus around first-class API objects, what are the fallbacks that we could potentially sort of quasi-standardize on to at least achieve some consensus, and then maybe continue to develop that into a API stuff later if we find out that enough people are using it. Kind of like we did with network policy, we started off with third-party objects or third-party resources and annotations. Maybe we could try to use that same approach here if we can achieve some consensus before we actually clear the bar of adding full API.
So I think the cheapest way to add network support is just to allow pod annotations and then use the annotation to indicate, like, for instance, a CNI network config, and then just trigger that specific network config instead of the default one. And then you have a default network config, and then you specify a specific one to.
Well, you immediately head into, if you take what is proposed to be first class and banish it to annotations and third-party objects, that doesn't remove some of the other problems. Like we were discussing how to support both thick and thin plugins, that problem remains.
Yeah, that is true. I mean, we could do the annotation thing, but still sort of use the same kind of format. Have an annotation that is the network name and then an annotation that is, or like network name, comma, plugin or something like that if we wanted to. I think there are ways to achieve the same result and still use annotations.
Yes. And that's what I'm going to do unless and until this group comes through with something else.
Well, and if you're going to do that and I'm going to do that and others are going to do that, wouldn't it be great if we could at least, kind of standardize on what that would look like?
I agree.
In the absence of any further strong feeling or discussion on this, should we essentially table for another 2 weeks so that people can go over and look at the use cases and then flame the mailing list about whether things are cloud native or not?
Maybe something more useful. Again, I'd like
try to avoid that last part.
I would like to hear if anybody does have a specific use case that does require services on more than one attachment for a pod. I'd like to hear the concrete use case.
Yeah, I think that would be a question I have too, because I think if you only need one if only one interface needs a service, then I think that makes some things quite a bit simpler and the bar a little bit easier to clear.
Hi, this is Coral from Intel. Can you hear me?
Yep. Yeah, we can hear you. Go ahead.
Regarding my question regarding the service endpoints requirement for the another interface. So I want to reiterate the same point what Dan has mentioned about IPTV. So for example, if you take in IPTV, for nowadays they are trying to create an instance of the setup box as a container. So what happens is whenever you initiate something from the IPTV, the corresponding instance is created as a container, and then for the container, then you require like two containers inside the pod. One container will be managing the control plane or management plane, and then another container will, for example, it can control data plane. So in that case, what happens is that you need one service which could able to manage the control plane or management plane, and another service which is required to manage the data plane. And these two services could be using two different net plugins. So the same example what Dan proposed, one could be the bridge plugin because it's a very low overlay network, and another could be SROV which requires the high throughput or high performance. So I think that is one of the use case I could say that it requires two services actually in Kubernetes.
So are you talking about containers that run on the set-top box or in the data center?
No, you create a corresponding instances in the container in your pod. I'm just giving you an example actually. It's
But
not like a real use case.
Did you misspeak? You said create the corresponding instances in the container. Did you mean in the data center?
Yeah, the corresponding for each user, the corresponding instances will be created as a container.
So each set-top box out in the field has a corresponding pod in the data center.
Yep, something like that. Actually, I'm not selling it. It's a real use case scenario, but I'm just mentioning it could be one of the scenario. I'm not saying that's what happening in the real field actually.
Okay, but my problem with that in terms of explaining it as a need for Kubernetes service on the data plane interface is the data plane interface of the pod in the data center is talking to a set-top box out in the field that is not a Kubernetes client.
No,
Not going to look up a Kubernetes service.
no, it can talk to other PNF physical network functions. From the physical network function, it can be given to the setup box. It's not like it directly the client is talking to the container. There could be some intermediate PNF will be communicating between the endpoints. For example, the endpoints means in this case it could be the setup box. So setup box will be communicating to the PNP. I mean the physical network function, and the physical network function is contacting the server, and in the server the corresponding container is spin off. So it's not like you thinking the one-to-one mapping from the real world VNF to the container. It's not like that.
Sure, I understand you can have more complicated network setups. My question that I'm trying to understand, though, is do you have a situation, in this situation, is the thing that needs to, is the data plane conversation, right, is the client, a Kubernetes client? Is it using Kubernetes protocols to reach the data, make the data plane connection?
No, for example, if suppose how you control application or a services without you having a services. For example, if you have two microservices or some other services, they have to talk to each other. They have to talk to through Kubernetes services only, right? So how you can expect the user to manage that own network? That is really difficult for the user to manage that particular services alone without Kubernetes as an orchestration engine.
I'm really confused about what kind of users you're talking about. In the world of TV, we've got users out at home, or we've got operators in the data center. We've got operators of the Kubernetes cluster, and then we've got application programmers who are deploying TV applications on the Kubernetes cluster. Which users are you talking about?
I mean the engineer who maintaining the data center. For example, if you are saying that two services, without the services, if you want to communicate with the two pods, it means that it directly, you mean to say that it's a direct communication between two Dockers or two Docker containers. It's not there is no communication between the two pods because you are segregating or separating the network from the Kubernetes itself. Then it becomes a burden for the network engineer, to maintain that own network without any orchestration engine at all.
Is there a way that could you mail kind of write up a short description of it and maybe even a diagram somewhere and send it to the mailing list? I think that might help a little bit because some of these concepts are quite complicated. So having
Okay.
either that or share your screen and draw it on a whiteboard.
Yeah, sure, I can do it. Yeah. Okay.
Yeah, that'd be awesome. Yeah, I mean, also in response to your question, Mike, I will take some time and try to come up with a diagram for my use case as well for the IPTV stuff I'm kind of talking about, because I feel like I'm not explaining it as well as I could. But I agree that, if it would be very interesting to find cases of service or cases that include services on two different interfaces.
Thank you both.
Yep. And I feel like also, I think I forgot to mention this earlier, one of the other general themes that I kind of pulled out was the split data plane control plane thing. And a lot of that had to do with performance of the data plane. And a lot of that was around either, direct NIC assignment to containers or SRIOV interfaces into containers to make sure that you had certain bandwidth guarantees and latency guarantees that you could not ensure if you had cluster traffic running over the same physical network as the actual data traffic or streaming media or whatever else. And I've quite a few different use cases that I listed here, as well as some other stuff that I had looked at, made heavy use of separate data plane. Again, whether or not those data plane interfaces actually require kube services is another question.
Right, but I completely agree that being able to control the QoS or segregate traffic for different QoS categories is an interesting use case.
Yep, I mean, especially with latency as well. I think maybe I put in one of the use cases around, for example, something like InfiniBand for storage networks. We have some use cases that want to do GlusterFS and that can run on InfiniBand for better performance than on Ethernet. And so, if for whatever reason your pod wants to mount that storage inside itself as opposed to have it mounted on the host and then mapped into the pod, then the pod needs some access to an InfiniBand interface, which may or may not actually be IP.
Right. And there's kind of a general theme here. I'm not quite sure you pulled out, right? But it gets into this name calling about cluster native, right? At some level, we say, look, we have all sorts of stuff we want to implement and deploy in Kubernetes because it's actually a nice scalable orchestration engine, and there's stuff like databases and media servers and all sorts of stuff that is, it's not 12-factor apps, but it seems reasonable to say, yeah, let's see if we can make Kubernetes manage this stuff.
Unfortunately, I think we're preaching to the choir on this particular call.
I think it comes back again to that bar between where does Kubernetes provide features natively or extension points to allow that to happen. Like there's a world where there's some incubator project or something that implements this and is kind of blessed by the SIG and the community, but might not be baked into the core Kubernetes components or API.
Well, and again, maybe the way to approach this is the same thing we did with network policy, which is have annotations that actually describe the networks and then have the network objects be third-party resources for the moment. That doesn't solve the question of how do you get information about interface and IPs back into Kubernetes, nor does it solve the multiple IPs per pod problem that's sort of orthogonal and sort of related, but maybe it's a starting point that doesn't have to clear that bar initially.
Yeah, and I think that's a starting point for any API changes that we want to make.
True. All right. Why don't we then we probably talk this one out unless anybody else wants to bring something up. I would suggest that people continue to add use cases that aren't already necessarily covered in that 14 bullet point list. And take a look at them. I would say let's debate them on the SIG mailing list. It's a little hard to keep track of all the comments in the Google Doc. So let's see, that would be number one. And then, maybe we can try to put together a proposal over the next 2 weeks for, instead of making full Cube API objects, how to do this as annotations and third-party resources for the time being.
That sounds good to me. So shall we take it to the mailing list and give people 15 minutes back?
Yep, works for me.
All right.
Okay, so next
Thanks,
meeting 2 weeks, right?
Yes.
Or is that 1 week?
Is there?
2 weeks.
It should be 2 weeks.
Yep. All right, so 18th. All right.
All right. Thank you all.
Yep.
Bye.
Thanks, everybody.